What if I told you that one of the most damning reports on German tank design during World War II didn't come from an Allied spy, but from the German army's own top engineers? And the crucial piece of evidence that started it all wasn't a stolen blueprint or a secret document. It was a captured American tank, a machine that would fundamentally challenge everything they thought they knew about armored warfare. Our story begins in the heat and dust of Tunisia in February of 1943. The American army was still green, learning hard lessons against the battle-hardened Afrika Korps. During the chaotic fighting around the Kasserine Pass, German forces stumbled upon a prize of immense value. It wasn't a burned-out husk or a wreck they had to tow. It was a fully functional, ready-for-battle American M4 Sherman, nicknamed War Daddy II. For the German technical intelligence teams, this was like striking gold. Here was a chance to finally get under the hood of the tank that was pouring off American assembly lines in staggering numbers. But before they could ship it back to Germany for a full teardown, they had to get it from the front lines to a seaport. And this is where the first shock came. The journey ahead was over 350 kilometers, or about 220 miles, across some of the most unforgiving terrain in North Africa. For a German tank crew, a trip like that in their own advanced Panzers or the new, mighty Tiger would have been a maintenance nightmare. They would have expected at least a half-dozen breakdowns, from engine trouble to transmission failures to busted suspensions. It was just the accepted cost of operating their complex, over-engineered machines. So a German crew climbed into the captured Sherman and started driving. And they kept driving. And the Sherman just kept working. It rumbled over rocky ground, churned through sandy washes, and endured the grueling mileage without a single significant mechanical failure. Let that sink in. For the German soldiers nursing this American beast across the desert, it must have been a revelation. They were used to treating their own tanks like delicate, temperamental race cars. This Sherman, by comparison, felt more like a farm tractor. It just refused to quit. When War Daddy II finally rolled into the port, it wasn't just a captured enemy vehicle anymore. It was a rolling, 30-ton question mark. It was a testament to a completely different design philosophy, one that prioritized rugged simplicity and mechanical endurance above all else. The long drive across Tunisia was just its first test, an impromptu trial that it passed with flying colors. But the real examination was about to begin. Once the Sherman was loaded onto a ship and sent to Germany, it was delivered into the hands of the meticulous, demanding engineers of the German Army Ordnance Department, the Heereswaffenamt. And the secrets they were about to uncover would send shockwaves all the way up to the highest levels of German command. So when the Sherman tank, War Daddy II, arrived at the Kummersdorf proving ground, you can bet the German engineers were ready. Imagine a team of the world's most meticulous and respected automotive minds, men who designed the intricate final drives of the Panzer and the Tiger, gathering around this dusty American machine. You might think the first thing they would do is measure the armor thickness or test the 75mm gun. But they didn't. They were far more interested in the mystery that had presented itself in Tunisia. How did this tank drive over 200 miles without a single breakdown? Their own tanks were plagued by transmission and final drive failures. It was the Achilles heel of their otherwise formidable designs. So with clinical precision, they went straight for the Sherman's guts. They drained the fluids, unbolted the massive transmission housing, and hoisted it out of the hull. This was the moment of truth. What kind of mechanical wizardry were the Americans using? When they finally cracked open the casing, they didn't find what they were expecting. German transmissions, like those in the Panther and Tiger, relied on straight-cut or Speer gears. These are simple gears, strong but incredibly demanding. For them to work without shattering, they had to be made from the highest quality hardened steel and manufactured to impossibly fine tolerances. Even the slightest misalignment under the stress of combat could cause them to strip or fail. But inside the Sherman's transmission, the Germans found something different. They found herringbone gears. If you look at one, you can see why it gets the name. The teeth are cut in a V-shape, like the skeleton of a fish. The Germans were immediately and profoundly impressed. They understood the genius of it in an instant. Unlike a straight-cut gear, where all the force smashes onto one tooth at a time, the herringbone gear engages smoothly and gradually. The load is spread across multiple teeth at once. This design is quieter, it produces less vibration, and crucially, it's self-centering. It's inherently more forgiving. It didn't require the almost fanatical level of precision machining that German gears demanded. The Americans had engineered a solution that was both incredibly durable and much easier to mass-produce. It was a completely different way of thinking. German engineering philosophy was to overcome a problem with brute force and perfect manufacturing. The American approach was to design the problem out of existence. This discovery in the transmission was the first major shock. It was a sign that the Americans weren't just building a lot of tanks, they were building them smart. The gears were a marvel of reliable, mass-producible design. But a great transmission is useless without a great engine to power it, and that was the next mystery the Germans were determined to solve. But the genius of the American design, as the Germans at Kummersdorf were quickly learning, didn't just stop with the clever shape of the gears. It extended to the entire philosophy of how a soldier was meant to interact with the machine. What's the one thing everyone thinks of when they imagine driving a World War II tank? It's that awful, violent sound of grinding gears, the lurching, and the struggle. The Germans certainly thought of it because it was a daily reality for their own crews. But when they started putting the captured Sherman through its paces on the test track, they discovered something astonishing. The Sherman had a synchronized manual transmission. For any of us who have driven an old car, that sounds normal. But in the world of 1940s tank design, it was a revolution. It meant that the American tank driver didn't need to be a highly trained specialist with the leg strength of a powerlifter and the delicate touch of a surgeon. The Sherman had 5 forward gears and a single reverse, and shifting between them was almost as easy as driving a civilian truck. You just pressed the clutch, moved the lever, and the gears meshed smoothly. There was no need for the complicated, skill-intensive ritual of double clutching. This stood in stark, brutal contrast to German tanks like the Panther and the Tiger. Their transmissions were marvels of engineering, but they were unforgiving crash boxes. To shift gears in a Panther, the driver had to perform a precise sequence of movements, depressing the clutch, shifting to neutral, releasing the clutch, blipping the throttle to match engine and transmission speed, then clutching again to slam it into the next gear. A missed shift wasn't just embarrassing, it could strip the gears and destroy a transmission that was incredibly expensive and time-consuming to replace in the field. This meant that a German tank driver had to be a master mechanic, a man trained for months just to operate the vehicle without breaking it. The Americans, on the other hand, had designed the complexity out of the system entirely. They understood they'd be training hundreds of thousands of farm boys, mechanics, and clerks to be tankers. They needed a tank that a reasonably competent person could learn to drive quickly and effectively. To the German engineers, this was a paradigm shift. They had always aimed for peak performance, assuming the operator would be an expert. The Americans had aimed for supreme usability, assuming the operator would be an ordinary GI. The Sherman wasn't just a weapon. It was a user-friendly tool of war. This ease of use, combined with the indestructible herringbone gears, explained the transmission's legendary reliability. But a transmission is only half of the powertrain puzzle. The German engineers now turned their attention to the engine, the heart of the beast. Based on their own designs, they expected to find a sophisticated, liquid-cooled, purpose-built tank engine. What they found instead would defy all logic and convention. The whispers from the Kummersdorf proving ground were starting to cause a stir in the highest echelons of the Reich. Reports of an American tank with a shockingly reliable transmission were one thing on paper, but seeing is believing. In June of 1943, the notoriously efficient Reich Minister for Armaments, Speer, decided he needed to see for himself. Imagine the scene. On one side, you have Germany's top tank designers and military brass, men who have staked their reputations on building the world's most advanced and powerful fighting vehicles. On the other side, parked and waiting, is the dusty American Sherman, and watching them all is the man who holds the purse strings for the entire German war machine. The day's event was a simple, brutal test of mobility. A series of steep, man-made slopes designed to push a tank's powertrain to its absolute limit. First up was the captured War Daddy II. The German test driver, now familiar with its forgiving controls, revved the engine. The Sherman moved forward, engaged the slope, and just climbed. There was no drama, no lurching, no grinding sound of tortured metal. It ascended smoothly, crested the top, and came back down as if it were just another day's work. It set a flawless benchmark. The German engineers must have felt a knot tightening in their stomachs. Next came the pride of the Panzer IV, the brand-new Panther tank. This was their thoroughbred, a machine designed with sloping armor and a powerful, long-barreled 75mm gun to dominate the battlefield. It approached the same slope. The powerful Maybach engine roared, but the ascent was anything but smooth. The tank strained, the driver wrestled with the complex transmission, and the whole vehicle seemed to struggle under its own weight. It eventually made it to the top, but the official report stated it barely matched the Sherman's performance. It looked difficult, stressful, and mechanically unsympathetic. Then came the real moment of dread. It was time for the Ferdinand, a colossal 65-ton tank destroyer armed with the fearsome 88mm cannon. It was a mobile fortress, a testament to German ambition. The massive vehicle began its climb, the twin engines whining under the immense load. It crawled partway up the slope, straining, and then it just stopped. It stalled out, defeated not by an enemy shell, but by a hill. The silence must have been deafening, the embarrassment radiating from the red-faced designers. Right there in front of Albert Speer, the simple American tank had effortlessly done what Germany's cutting-edge heavy armor could not. For Speer, this wasn't about a single duel, it was about the bigger picture. It was a terrifyingly clear demonstration of a deep-seated problem in their design philosophy. The question was no longer just about the transmission. What was powering this American workhorse, allowing it to perform so effortlessly? The engineers now turned their full attention to the Sherman's engine bay, and what they found there was even more unorthodox and more brilliant than the gears in its transmission. That humiliating demonstration in front of Albert Speer was a single, bad day for German engineering. But what the testing at Kummersdorf uncovered next was far more terrifying. It wasn't about one embarrassing moment on a test slope. It was a long, slow-motion catastrophe playing out on every front. The engineers didn't just test the Sherman for a day. They ran it mercilessly around their test tracks, simulating combat conditions, long road marches, everything they could throw at it. And the numbers that came back were jaw-dropping. The captured Sherman could travel over 2,000 kilometers, that's about 1,250 miles, before it required what they considered a major overhaul. Things like pulling the engine or rebuilding that rock-solid transmission. Now let's put that in perspective. Their own brand-new Panther, the tank that was supposed to sweep the Russian front, was lucky to get 500 kilometers before needing the same level of intensive, depot-level maintenance. Do the math. The American tank was, on average, 4 times more reliable in terms of major breakdowns, and this wasn't just a problem on the test track. This was a disaster in the field. The grim reality of the Panther's flaws became hideously apparent during the Battle of Kursk, the largest tank battle in history. The Panther was the key to their battle plan, yet on any given day, its operational readiness rates were abysmal, hovering between a catastrophic 16 to 25%. Think about that from a general's perspective. For every 4 brand-new supertanks you're promised, only one is actually ready to fight. The other 3 are sitting behind the lines with their engine decks open, waiting for overworked mechanics to perform yet another complex repair on their over-engineered final drives or transmissions. Meanwhile, the Americans were fielding an army of tanks that just worked, while German crews were fighting their own machines as much as they were fighting the enemy. American tankers could count on their Shermans to start up, get to the battle, and stay in the fight. The German engineers now understood the brutal math. Their quest for technological perfection had created fragile beasts, while the Americans' focus on practical reliability had created a war winner. The robust, easy-to-use transmission was a huge part of this success, but it couldn't explain everything. The difference in operational endurance was too vast. The ultimate source of the Shermans' incredible stamina, the final piece of the puzzle that left the Germans in awe, was waiting for them under the engine hatch. And the type of engine they found inside wasn't just unconventional for a tank. It was something they never would have even considered. The German engineers at Kummersdorf were hunting for a single magic component that made the Shermans so durable. But the real secret wasn't a piece of metal they could hold in their hands. It was the invisible, unstoppable force of American mass production, and it was a weapon Germany simply could not counter. Before they even got to the Sherman's engine, the engineers began to notice something about the tank's construction. The welds were clean but functional. The castings were efficient, not overly finished. To the German mind, accustomed to a near-artisanal level of craftsmanship even on military hardware, it looked crude. But then they started taking measurements, and they realized the genius of it. The Sherman wasn't built like a single, bespoke machine. It was assembled from a universe of perfectly interchangeable parts. This tank, War Daddy 2, could have been built at any one of 11 different American factories. It could have been made by Ford, Chrysler, or the Federal Machine and Welder Company. And the crucial point was, it didn't matter. A drive sprocket made by the Lima Locomotive Works in Ohio would fit perfectly onto a transmission assembled by General Motors in Michigan. This was the power of the American automotive industry unleashed. They weren't just building tanks. They were applying the revolutionary principles of Henry Ford to the art of war. This concept was utterly alien to the German way of doing things. Take the Panther tank, for example. It was built by several different manufacturers, like MAN and Daimler-Benz. But their industrial base lacked this fanatical devotion to standardization. Each factory, while working from the same basic blueprint, would introduce their own small changes, their own little improvements. The result was a logistical nightmare. A replacement part for a Panther built by MAN might be a few millimeters off and simply wouldn't fit a Panther built by Daimler-Benz. This meant that German supply depots had to stock not just Panther parts, but specific parts for each manufacturer's version of the Panther. It made field repairs a slow, frustrating, and often impossible task. The Americans had solved this problem before the first Sherman ever rolled off the line. Their system meant that a single, unified supply chain could support the entire Sherman fleet anywhere in the world. A crate of spare parts shipped to the deserts of Africa would work just as well for a tank fighting in the fields of France. This philosophy of standardized, interchangeable parts was the secret behind the Sherman's incredible uptime and ease of repair. It was a manufacturing triumph that explained the logistical superiority of the Allied forces, but it still didn't fully explain the raw, brute force endurance the engineers had witnessed. For that answer, they finally had to look at the power plant they had so carefully set aside. And what they discovered under the engine deck was an aeronautical marvel that had no business being in a tank. So the German engineers had uncovered the secrets of the Sherman's reliable transmission and the genius of its mass-produced, standardized parts. But what did all this technical data actually mean on the battlefield? It meant everything. It created two completely different mindsets for the crews fighting inside these machines. For a German tank commander in a Panther or a Tiger, his first enemy wasn't the Russians or the Americans. It was his own tank. Every lurch, every strange noise from the engine, every moment of strain on the transmission was a cause for anxiety. The question, will we make it to the battle, was just as important as, will we win the battle? This constant, gnawing worry about mechanical failure had a profound psychological impact. It meant that every decision was filtered through a lens of mechanical preservation. German commanders became incredibly cautious. They had to be. Their multi-million Reichsmark supertanks were just too fragile. In fact, the Panther's unreliability was so bad that strict orders were issued forbidding them from making long road marches. Think about that. A tank, the very symbol of mobile warfare, was often not trusted to move under its own power for any significant distance. For any strategic relocation over 100 kilometers or so, Panthers were painstakingly loaded onto railway flat cars. This tethered entire panzer divisions to the vulnerable rail network and dramatically slowed down their operational tempo. Now, contrast that with the experience of the American Sherman crew. When a Sherman commander was given an order to advance 50 miles, his primary concern was the enemy. He wasn't thinking about whether his final drive would survive the journey. He could trust his machine. This reliability gave American commanders incredible tactical flexibility. They could conduct rapid, sweeping flanking maneuvers, long-range pursuits, and audacious penetrations deep into enemy territory, all with a high degree of confidence that their armored columns would actually arrive intact. While German crews were hoarding spare parts and praying their transmissions wouldn't fail, American GIS could focus on tactics, gunnery, and teamwork. Their cognitive load was lighter. The tank was a tool that served them, not a demanding master they had to constantly appease. The Sherman's simplicity and toughness meant less time in the workshop and more time at the front. It allowed Allied units to maintain a relentless, grinding pressure that the Germans, with their brittle and overstretched armored forces, simply couldn't sustain. This operational freedom was a direct result of the design choices we've already discussed. But the final, and perhaps most stunning, piece of the puzzle lay in the Sherman's engine bay. The Germans expected to find a typical V8 or V12 liquid-cooled engine, the standard for high-performance vehicles. What they found instead looked like it had been ripped straight out of an airplane. What's the single greatest compliment you can pay to your enemy's equipment? It isn't praising it in a post-war memoir. It's capturing it, slapping your own insignia on the side, and immediately turning it against them. And that is precisely what German forces on every front did with every working Sherman tank they could get their hands on. The findings of the Kummersdorf engineers weren't just an academic exercise. They confirmed what German soldiers in the field were discovering for themselves. When a panzer division captured an intact Sherman, they didn't see an inferior enemy machine. They saw a godsend. They saw a tank that starts when you need it to, a transmission that doesn't threaten to grenade itself, and a machine that lets the crew focus on fighting instead of worrying about breaking down. And here is the most telling detail of all. Unlike most captured equipment, which German engineers loved to tinker with and improve, they left the Shermans almost entirely alone. They would paint a large Balkan cruise on the hull and turret to prevent friendly fire incidents, maybe give it a coat of Dunkelgelb paint, and then send it right back into action. They didn't modify the engine, they didn't try to upgrade the transmission, they didn't change the running gear. They didn't need to. The tank simply worked as designed. This wasn't a rare occurrence. These captured tanks, or Beutepanzer, as they were called, became highly prized assets. We have documented accounts from German units on both the eastern and western fronts, where commanders specifically requested captured Shermans for critical missions. Not their own Panthers, not the mighty Tiger. They wanted the American tank. And what kinds of missions were these? They were long-range reconnaissance patrols, lightning raids deep behind enemy lines, and desperate flanking attacks. Any operation where sustained reliability was the absolute key to survival. When a German commander needed to send a small force on a mission where a breakdown meant certain capture or annihilation, he put his men in a Sherman. It was the ultimate vote of confidence, an admission on the battlefield that the enemy's philosophy of rugged simplicity was, in many critical situations, superior to their own complex designs. This battlefield reputation was the final, irrefutable proof. The user-friendly controls, the tough-as-nails transmission, and the standardized parts all added up to a weapons system that was trusted more by its enemies than their own equipment was. But all of this, from the Tunisian desert trek to the desperate raids in France, depended on the heart of the machine. The German engineers now knew what the Sherman could do. It was time to find out exactly what was powering it. The battlefield success of captured Shermans was a stark confirmation of German suspicions. But the admiration and even envy the German soldiers felt was about to be dwarfed by a set of numbers so vast, so overwhelming, they defied belief. The truth is, the Sherman tank's greatest weapon wasn't its cannon or its armor. It was the factory that built it, multiplied by thousands. Between 1942 and 1945, a period of just over 3 years, American industry produced an astonishing 49,324 Sherman tanks. Let that number sink in, almost 50,000. Now let's compare that to the entire wartime production of Germany's main battle tanks. If you take every Panzer IV, every Panther, every legendary Tiger I, and every monstrous King Tiger that Germany managed to build throughout the entire war, the total number still falls short of just the Sherman alone. America didn't just outproduce Germany, it buried Germany under a mountain of steel. And this numerical superiority was magnified by a brutal reality on the ground. While American tank factories in Detroit, Ohio, and Michigan hummed along 24 hours a day, safe behind the shield of two oceans, German manufacturing centers were being systematically flattened. A factory making Panther final drives in Friedrichshafen could be hit by 1,000 Allied bombers one night, and the production of every Panther in the Reich would grind to a halt. Skilled German workers were constantly being called up to the front, replaced by less experienced labor, or worse, by slaves who had little motivation to ensure quality control. The result was inconsistent quality, shoddy parts, and constant disruption. Meanwhile, in America, the arsenal of democracy was hitting its stride. The workers weren't just safe, they were motivated. Building a Sherman wasn't just a job, it was a patriotic duty. This combination of a secure industrial base and a dedicated workforce meant that the 10,000th Sherman was built to the exact same high standard of reliability as the first. This was the strategic context that the engineers at Kummersdorf were grappling with. They were a handful of brilliant men trying to perfect a handful of exquisite but fragile machines, while their enemy was fighting the war with a completely different doctrine. A doctrine of overwhelming, reliable, and unstoppable mass. The production war was already lost, but the German engineers still had one final, nagging technical question to answer. They understood the transmission, they understood the manufacturing, they understood the terrifying industrial disparity. It was finally time to analyze the Sherman's most unusual and perhaps most brilliant component, the engine. So what was the final, stunning secret the German engineers found in the Sherman's engine bay? What was the powerhouse behind this miracle of reliability? It wasn't a sleek, purpose-built V12 tank engine like their own Maybachs. What they hoisted out of the M4A1 was something that, to them, made absolutely no sense. It was an airplane engine. Specifically, it was the Wright Continental R975, a massive, 9-cylinder, air-cooled radial engine. To the Germans, whose liquid-cooled engines were masterpieces of compact, high-performance design, this must have seemed crude and bizarre. A big, round, bulky aircraft engine shoehorned into the back of a tank. But they quickly understood the brutal logic of it. Being air-cooled, it had no vulnerable radiators, no rubber hoses to burst, and no coolant to leak out on the battlefield. And just like the transmission, it was a mature, proven design that had been in mass production for years. It was another off-the-shelf solution, a testament to American pragmatism. And that was the final lightbulb moment. The user-friendly transmission, the standardized parts, the overwhelming numbers, and now a rugged, reliable aircraft engine. It wasn't one single thing. It was a complete philosophy, a system built for total war, not for a glowing spec sheet. The war, of course, ended. The Third Reich collapsed, under the combined weight of Allied industrial might and military pressure. But the lessons learned from that captured Sherman did not die in the rubble of Berlin. They were burned into the memory of a generation of German designers. Years later, when the time came for a new West Germany to build a new tank for a new army, the engineers who had witnessed the Panther's failures and studied the Sherman's successes faced a choice. Would they return to the old philosophy of building the most powerful, most complex, most advanced tank imaginable, or would they embrace the hard-won wisdom from the past? They chose wisdom. They named their new tank the Leopard 1. And it was, in its soul, a very different beast from its wartime ancestors. The Leopard 1 consciously sacrificed thick armor for speed and mobility. Its designers prioritized ease of maintenance, crew ergonomics, and above all, mechanical reliability. They built a tank that could be counted on, one that could travel long distances without a breakdown, a tank whose crews could focus on fighting. They had learned the Sherman's most important lesson. The Leopard 1 wasn't a copy of the Sherman, but its philosophical DNA was undeniable. The journey of that one American tank, War Daddy 2, from the dust of Tunisia to the proving grounds of Kummersdorf, had a legacy that lasted for decades. It was a teacher, a rolling piece of evidence that proved, beyond a shadow of a doubt, that a good enough tank you can count on is infinitely better than a perfect tank that never makes it to the fight.